Yeah, this is the first problem. Which of the following is irrational numbers? So, of course, clearly it is rational number. And if you see this, root 8, root 8 can be written as 2 root 2. Okay. And root 12, it can be written as 4 into 3. 4 you can write 2 root 3. 4 root 3 can be equal to 2 root 3. Okay. So root 8 means 2 root 2 plus root 2 multiplied by 2 root 3 minus root 3. 2 root 2 plus root 2. How much is this? 3 root 2. 2 root 3 minus root 3. Root 3. So of course, if you do multiplication, then it will be 3 root 6. And 3 root 6 is irrational. If you see third option, root 6 by root 8. So 6 by 8 you can write under root. And it is getting cancelled 3 out of 4 times in 2 table. So root 3 by 2. Root 3 by 2 is also a irrational number. And root 8 we already solved this one. Root 8 is 2 root 2 minus root 2 multiplied by root 18 will be 9 twos. Root 18 will be 9 twos. 9 twos are 18 plus root 2. So this is what root 2 and it is multiplied by 3 root 2 plus root 2. So root 2 is multiplied by 4 root 2. So this value is equal to 4 into 2 because root 2 into root 2 square. 4 2, it is rational. So these out of all this, the answers are second, rational, and third, irrational. Suppose f from D to capital R. D stands for domain. It is standing for a domain. And R is a range actually. And of course, this R indicates real number system. Is a function defined by f of x is equal to square root of x square minus 25 divided by x plus 5, where D is a subset of Z. So Z means set of integers. Domain, that means only numbers exist in this D. Let capital A be the set of integers which are not in the domain of F. So actually D is a subset of Z and always D contains integers, negative, positive, everything. And A is the set of integers which are not in the domain. Okay. So it is subset of Z and some integers will be existed in D. Some are not existed in D. And of course, they are integers. So those integers will exist in capital A. Then the domain are not in the domain of F. Then find the cardinality of this set A. Actually, you can see it is a question of finding domain. Finding domain. So actually, this is a rational type of function. Numerator and denominator exist. First, we will analyze the denominator for existence. So denominator is x plus 5. For existence of this f of x, it should not be 0. That is rule number 1. That means x cannot be minus 5. Okay, that is condition 1. If we see numerator is also it contains a square root. Square root means for existence of the square root value. So x square minus 25 must be greater than or equal to 0. Then only it exists. Otherwise, if it is negative, we are getting some complex numbers, not real numbers. But here they are talking about output will be real numbers, not complex numbers. So this function must be greater than or equal to 0. So you can write x plus 5 into x minus 5 greater than or equal to 0. So take a real line. This is from minus infinity to plus infinity. And if you see the first factor x plus 5, what is the root of that one? Minus 5. And x minus 5 root was 5. And we know that this line, real line, it is a positive area. This is negative, and this is positive area. This inequality requires positive values. That means every number here in this part will be the domain, and also this part. And if you see this condition, it is not equal to minus 5. That means we should not consider this part. So except minus 5. That means this is D, and this is also D. So in real line or in integer set of integers, so which is not D, that will be A. So that means this area will be A. And A is a set of integers. So you can write A is equal to, we should not take minus 5. So in this area, you can guess minus 4 exists, minus 3, minus 2. Only integers will be taken, no other numbers. So minus 1, 0, 1, 2, 3. 5 is included in this part, and minus 5 is not included in this part. So you can take minus 5 also in the set of A. Why? Because we already avoided in the domain part. So which is avoided in the domain part will be existed in the set A. So if you see, if you count he is asking the cardinality of this set. So n of A will be 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers is there in total. So answer of this question is 9. Yeah, here we've missed this 4. So sorry for this. This is 10 numbers exist in total. So count it again. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and minus 1. Minus 5. So totally from here, 5 numbers and these 5 numbers. So total 10 is the correct answer.